Right, so question 2, part A. We're asked to find the size of angle E, which is this one up here, angle E. Using angles on a straight line down here, we've got 100, so that must be 80. Of course, we've got parallel lines, we should extend those. Good technique with parallel lines. This is an isosceles triangle, so this one must be 80. And then using angles in a triangle, add to 180. We've got 160, so that must be 20. Right, so now we need to write that out in a sequence of steps. So we first found angle M to equal 80 degrees, and the reason was angles on a straight line. Sum 180. Then we found angle G to also equal 80, and that was using base angles in an isosceles triangle are equal. And lastly, we found angle E to equal 20 degrees, and that was using angles in a triangle sum 180. You might have done it differently, as long as you set it out. Now part B uses a similar idea. And this time we're asked to find an expression for the size of angle R in terms of x and y. So you'll notice there's no numbers on this diagram. We're asked to find an expression for R here using the x and y letters. So if we just make our parallel lines longer, and there are lots of different ways you can do this, so I'll just show you one way. We could work out angle A here is exactly the same as x because they're alternate. We could use this triangle here, angles in a triangle, sum 180 to find R if we knew N. N is on a straight line with G. G and M are equal, and we know how to find M. We know that M is 180 minus x minus y, and that's because of angles on a straight line. And of course G and M are the same because they're in the isosceles triangle. Now an expression for N would be 180 minus G, and that there is our expression for G. So 180 minus 180, they'll cancel out. Now I've got two minuses there, and of course we're multiplying. You can think of this as -1. Negative times negative will make that positive x, and similarly with the y, when we multiply, two minuses there, make that plus y. So that would give me an expression for that. And then to find R, we need to do 180 minus both of those. So now that we have a plan, we'll start explaining what we've done. We found angle M to be 180 minus x minus y from angles on a straight line, sum 180. We found angle G to be the same. That was using base angles in an isosceles triangle are equal. We also found angle A to equal x. That was using alternate angles in parallel lines are equal. Right, next thing we found was N using the G. N equals x plus y. That was using angles on a straight line. And if you just want to refer to the algebra there. So lastly, angle R is going to equal 180 minus that angle minus the x plus y, and because it's x plus y we'll just put it in brackets like that. So doing a little bit of algebra on that, and the reason for that was angles in a triangle, sum 180. So that means angle R is going to equal 180. Now I've got minus x minus another x. Remember that's minus x there, so that would be minus two lots of x minus a y. And that's the answer we need. Right, moving on to the next one. And the next one I can see has got a polygon on it. In fact, it's a 9-sided one. Now, questions to do with polygons, we need to remember the rule, n minus 2 times 180. That would give me the sum of all the interior angles. And of course, exterior angles always sum to 360, no matter how many sides. Now it describes edge angles. We don't learn about edge angles, but it tells us what they are, and it shows us what they are as well. How large is each for a regular nonagon? Now it says it's regular, which is helpful, so we'll put those on to show that it's regular, which means all the interior angles are the same, and obviously all the edge angles are too. Now I don't know how to find an edge angle, but I can find one interior angle of a regular nonagon, so we'll just put some working in for that. We call that one x and we can call that y. So to find y, we'd have to go 9 minus 2 times 180. There are 9 sides. N equals 9 in that formula. So that would give me the sum of all the interior angles. So working that out, 1260. And then of course we'd have to divide by 9 because there are 9 interior angles in there, and they're all the same. So dividing that by 9, we get 140. So each interior angle equals 140 because interior angles in a polygon sum n minus 2 times 180. Right, so therefore angle x, the edge angle, is going to equal 360 minus that, so that's 220 degrees, and that was using angles at a point. Sum 360. And there are other ways you can answer that using exterior angles as well. Right, part 2. Show that the expression for the total of the edge angles of any polygon with n sides is, so we're thinking about any shaped polygon. It doesn't have to be regular, it doesn't mention regular, which is a shame actually because it would be easier. For any polygon, we want to find out what all of those would add up to. We can work out what all the interior angles add up to. Remember it's got n sides, so n minus 2 times 180 equals sum of interior angles. Now at each vertex, of course, the interior angle and the edge angle will add up to 360. So working our way around the circle, we'd actually get n lots of 360 would be the total for adding them all up. And then if I can subtract the sum of the interior angles, and the sum of the interior angles is this one here, we might write the 180 in the front this time, then I should be left with the sum of the edge angles. So just think about that again. At each vertex, the interior and edge angle add to 360, so I'll have n vertices if there are n sides. So I'll have n lots of 360. And then if I subtract the sum, all those interior angles away from that total, then all I'll have left is the sum of the exterior edge angles. So let's work with this. We're expanding. We have got negative 180 as we expand, so I'll get negative 180n, and then when I expand here, 2 negatives make a positive. 180 times 2 is 360. So looking at that, 360 minus 180 will be 180n plus 360. And that's my sum of edge angles. Common factor inside both of those terms is 180. We bring that out the front, leaving me with n plus 2. Equals the sum of the edge angles, which is what we were asked to prove. Right, here's another way of doing it with the exterior angles. So if we just, you can think about that one, but also if we think about an exterior angle all the way around the polygon, we know that the exterior angles sum to 360. And if I were to complete that, the exterior angles, by adding 180 to each one, then I've got myself an edge angle. So the edge angle is actually one individual exterior angle plus 180. So summing all those together, you'll get 360 for the exterior, plus we would need n lots of 180. We'd need to add 180 to each exterior angle, and once again common factor of 180, leaving me with 2 plus n, which is what we were asked to prove.